In this screencast, I'm going to explain the issue with step size in task 1 for the final dataset, and I will also explain the difference between batch and stochastic gradient descent and how they attempt to overcome this issue. First, I will walk through the code. For implementation of batch gradient descent, code is almost the same, but the only difference was that I took a list of step size instead of a fixed step size. And for the implementation of stochastic gradient descent, I first randomly picked picked a starting point and initialized step size, mean values, and the number of iterations with no improvement. And then when step into the loop, a data point was randomly selected and it was used to determine the gradient or direction based on just this data point, and and then we took a step in the direction indicated, and it cycled over the data repeatedly until it reached a starting point, which is a minimum value. And there is still a possibility that we might circle around near a minimum value forever. So whenever we stop getting improvement, we need to decrease the step size and eventually quit. So when it when every time when a new minimum value occurred, uh, we we need to capture that and and stop the and quit the loop. Um, and if we didn't get the minimum value, we want to keep going on the iteration and gradually shrink the step size. In terms of the difference, batch gradient descent requires to compute the gradient for the whole dataset, and this make each step um, might take a long time and cause unnecessary computation, while stochastic gradient descent only computes the gradient and take a small step for only one data point at a time, and it reduces lots of computations. And the issue in task 1 for the last data set was that the next step was the next step would keep bouncing around as we took a fixed step size to deal with the issue. Batch stochastic In batch stochastic gradient descent, I took a list of step sizes, and at each step size, well, we compute we compute all next step based on the list of step sizes and choosing the step size that minimize the value of the sum of squared function. And for stochastic gradient descent, we initialized a fixed step size at first, but and we gradually shrank step size over the loop, and this is the output for both implementation, um, and the results are very close. For the dataset 1, the minimum value occurred at 1.67 um, and 5.07, and the least regression line was y equal to 5.07 plus 1.67 multiply x, and for data set 2, it started at minus 6, 2 and 2, and the minimum occurred at 22.94 and 0.9, and so this linear regression line is y equal to 0.9 plus 22.94 multiply x, and the output of stochastic gradient descent is really close. So that's all.